Our topic today, module number 2, I'm gonna talk about beams and frames. This week will be very important, so you can expect 2 questions from this week in your coming exam. First part in this module, I'm gonna talk about, not talking, but just to remind you about types of support. We have 3 types of support. Probably your beam is fixed to this wall. So this connection can be represented as a fixed support. In the real life, looks like this one, or looks like this one. You have column. In this case, we have beam. This beam is fixed to this wall. So this connection can be represented as a fixed support. This column is fixed to this base. So this connection can be represented as fixed support. In your problem, fixed support looks like something like this. Fixed looks like this for beam, or like this for columns. Do you remember how many reactions do you have if you have fixed support? Anybody still remember from engineering mechanics? If you have fixed support, any answer? Thank you. No. Thank you, Marcus. You are good. Megwell, if you have fixed support, okay. Just to remember, if you have fixed support, fixed, no rotation. No rotation. No translation. We don't have rotation, we don't have translation. So we have 3 reactions: vertical reaction, horizontal reaction, and moment. If you prevent the rotation of the support, that means we have a moment as a reaction. If you prevent translations in X and Y, horizontal and vertical, so we have 2 vertical and horizontal forces as a reaction, as reactions. So if you have fixed support, we have 3 reactions: 1 vertical force, 1 horizontal force, and 1 moment. Just remember. Okay. The second type of support called hinge support. This bridge is hinged to this base. So this connection can be represented as hinge support. This column is supported by this base by this hinge. So hinge will allow for rotation. So we don't have moment as a reaction. So hinge support looks like this. If you have a beam, the hinge support looks like this. If you have a column, this hinge support looks like this. If you have hinge support, we have 2 reactions: 1 vertical reaction and 1 horizontal reaction. Vertical reaction and horizontal reaction. So fixed support, we have 3 reactions. Hinge support, we have 2 reactions. The third one called roller support. Can you watch this cylinder underneath the bridge? This cylinder will allow for rotation and horizontal translation. This roller will allow for rotation and horizontal translation. So if you have roller support, looks like this. For beams, looks like this. For column, looks like this. Please pay attention. The difference between this shape, which is hinge, and this shape, which is roller. If you have roller support, we have 1 reaction, looks like this, or looks like this. So to summarize this slide, we have three types of support. Fixed support has three reactions. Hinge support has two reactions, and roller support has one reaction. Any question so far? If you have any question at any time, let me know, please. Guys, this week is very important. Please pay attention. This week is very important. We are building something for the next week. I have comment here. I have a comment. What will happen if you have roller like this or a roller like this? Okay, sorry guys, I'm sorry for this. So can you hear me right now and can you watch my screen? Okay, thank you. If you have a roller like this or like this or like this, we decided if you have roller support, we have one reaction. This reaction is horizontal reaction, vertical reaction, or what? What is the direction of reaction of this reaction in if you have a roller support? This point is very important. Please pay attention. This point is very important. Any answer? Any answer? What is the direction of this reaction? Thank you. Thank you, Benjamin. Yes, your reaction is only one reaction, perpendicular to the base of the roller. For this base. So the reaction for roller support is perpendicular to the base of the support. Keep it in your mind. So fixed support has three reactions. Hinge support has two reactions. Roller support has one reaction perpendicular to the base of the roller. Looks good? I believe you learned all of this information in engineering mechanics. That's right? Okay. Second part in our topic today, stability of structures. Your structure can be any structure can be divided to stable and unstable. If your structure is stable, can be divided to determinate or indeterminate. So we have three categories of structures. Pay attention. Structure can be stable and determinate, can be stable and indeterminate. The structure can be unstable. So we have three categories: stable and determinate, stable and indeterminate, and unstable. Guys, do you like your structure to be stable or unstable? What do you think from the meaning of these words? What do you think? Do you like your structure to be stable or unstable? Sure, we like our structure to be stable. Unstable means collapse. Unstable means failure. Unstable means people will die. So it doesn't make any sense to find any structure in this world which is unstable. Doesn't make any sense to say, hey, can you watch this structure? This structure is unstable. Doesn't make any sense because the structure will not wait for just a second to say it's unstable. Collapse will happen before saying, hey, it's unstable. So we don't like unstable structure. We like our structures to be stable. To be determinate or indeterminate, determinate you can solve with equilibrium equation. Indeterminate you cannot solve. cannot solve with equilibrium equation, but we have different methods to solve. We can use software, we can use computer, we can use anything else, but you cannot solve with equilibrium equation. So determinate or indeterminate, your structure is still good because the structure is stable. So one more time, your structure can be stable or unstable. If the structure is stable, I can say this structure is stable and determinate, or this structure is stable and indeterminate. Otherwise, your structure is unstable. Doesn't make any sense to say your structure is unstable and determinate, or unstable and determinate, or indeterminate, because if the structure is unstable, I don't need to solve it. Okay? How can I figure out the stability of the structure, stable or unstable? How can I determine or I figure out the determinate or indeterminate of the structure based on the relationship between number of unknowns and the number of equations? If the number of equations equal number of unknowns, your structure will be stable and determinate. If the number of unknowns greater than number of equations, stable and indeterminate. If the number of equations greater than number of unknowns, mathematically means we have less number of unknowns, but we have many number of equations. Doesn't make any sense mathematically. So your structure is unstable. Number of unknowns is the number of reactions. If you have a structure, you have reactions. How many reactions? This number or this number of reactions called number of unknowns. And the number of equations equal 3n. N is the number of bars. What is the meaning of number of bars? I will go through this during the examples. But at this moment, do you have any question? Do you have any question? If you have any question, let me know. So any beam or frame can be classified based on stability of as following: stable, determinate, stable, indeterminate, or unstable. How can I figure out the stability or determinacy of the structure based on the relationship between number of unknowns and the number of equations? What is the meaning of number of unknowns? Is the number of reaction. What is the meaning of number of equations? Equal 3n. N is the number of parts. Before starting our examples today, we have special cases. We have special cases. What do you mean by special cases? Your structure will be unstable regardless. What is the relationship between number of unknowns and the number of equations? I don't care about this relationship, and I can say this structure is unstable because this structure is a special case. We have two cases. If you find one of them, you can say without any thinking, this structure is unstable. The first one, if all, and please pay attention to all reactions are concurrent at one point. I'm sorry, what do you mean by concurrent? Okay, let's say about this structure. We have a structure, looks like L. We have two supports. This one is hinge. This one is roller. Hey, can you tell me how many reactions do you have at this support? We have two, one vertical and one horizontal. How many reactions at this support? It's roller. Okay, we have one reaction. Okay, Which direction? Do you remember that? Perpendicular to this base. Okay, so how many reactions total? We have 3. All of them, this one, and this one, and this one, all of them intersect at this point. If you extend this direction, and this one, and this one, all of them are concurrent at a point. That means this structure is unstable. Without thinking about the relationship between equations and unknowns, I don't care, because this structure is a special case. One more time. We have a beam, this beam, with 3 reactions. This one is roller, this one is roller, this one is roller. So each support has 1 reaction, perpendicular to this base, perpendicular to this base, perpendicular to this base. Can you extend the directions of this reaction? If you extend this one, extend this one, extend this one, all of them, please remember, all of them intersect at one point. That means this structure is unstable. The third one, we have 2 supports only. We have 1 reaction here, perpendicular, because this one is roller. This one is roller. So we have 1 reaction. The 2 reactions, if you extend this one and extend this one, all reactions are intersect at one point. So this structure will be unstable. So guys, regardless how many how many unknowns or how many equations do you have, the structure is unstable if all reactions are concurrent. Concurrent means intersect at one point. Any questions so far? Any questions so far? Okay, looks good. Looks good. Carolina, do you have any question? Okay. The second case, if all reactions are parallel. For this beam, we have 3 rollers. Roller support, roller, roller. So we have 3 reactions. This one will be perpendicular to the base, perpendicular, perpendicular. So all reactions, all of them, please remember all of them are parallel. So this structure will be unstable. The same case here, these lengths will make your reaction parallel. So this structure will be unstable. The same here, this one and this one and this one, all of them are parallel. So this structure will be unstable. So if all of your reactions are concurrent, the structure is unstable. If all of the reactions are parallel, the structure will be unstable. Regardless how many equations or how many unknowns. Example number 1. Let's do the first example. This structure, we should expect one equation or one question like this in your coming exam. Classify each of the following structures as statically determinate, or statically indeterminate, or unstable. We have 3 categories only. Can you go back? We have 3 categories only. You need to tell me this structure is stable or stable and determinate, stable and indeterminate, or unstable. So the question will say, hey, classify each of the following structure as statically determinate, statically indeterminate means stable, determinate, stable, indeterminate, or unstable. Okay, let's start with this one. We have roller here. We have hinge. So please, how many reactions do you have? We have one. How many reactions? We have two. So R equal 3, N equal 1. Do you remember that? R is the number of reactions. N is the number of parts. So how many parts? Actually, we have only one part. This part is 1. So N equal 1. How many reactions? 1, 2, 3. So R equal 3, N equal 1. So number of unknowns equal 3, which is R. Number of equations equal 3n. So 3 times 1 equal 3. That means number of unknowns equal number of equations. Number of equations equal 3n, number of unknowns equal R. And finally, you found number of unknowns equal number of equations. Number of unknowns equal number of equations. So your structure will be stable and determinate. My final conclusion, this structure will be stable and determinate. I am done. Piece of cake. It's very easy. Very easy. If you have any question, let me know. Okay, looks good. Before going through the rest, I need to explain something here. This member is one member. Probably this member can be connected to another member by something here called hinge. Like this. Can you see this one? This connection is hinge. Hinge connection. Or like this. Can be called pin or hinge, whatever. This one is called pin connection or hinge connection. Both of them works. Pin connection. So this connection can be called hinge connection or sometimes pin connection. I can make separation. I can separate the two parts, this member and this member. I can do separation. So this member alone and this member alone. As I told you, this connection can be called hinge or pin. If you have hinge, we have two reactions, one vertical and one horizontal. These two reactions will be the same value, but opposite direction. So the horizontal one will be the same value, but in opposite direction. The vertical reaction will be the same value, but opposite direction. So if this one is Y, this one will be Y. If this one is X, this one is X. The same values, but opposite direction. If you have pin connection, if you have hinge connection, please do separation. If you do separation at this location, we have two reactions. Will be the same on the other side, same values, but opposite direction. Same values, but opposite direction. Only for pin or hinge connection. If you have only pin or hinge connection, please make separation. If you do a separation, we have two reactions. On the other side, we have another two reactions, same values, but opposite directions. As I told you, if you have a member like this and another member like this, at this location, we have hinge connection or pin connection. I can do separation at this location, this part alone and this part alone. Make sure at this separation we have two reactions. The horizontal one will be the same value but opposite direction here. The vertical one will be the same value but in opposite direction. That means, can you tell me how many reactions at this location? How many reactions? Is it 2 or 4? What do you think? 2 or 4 unknowns? How many unknowns or how many reactions at this location? 2 or 4? 4 Jennifer, 4 Carolina. Any other answer? Two Benjamin. Guys, if this reaction is 5, this one will be 5, but in opposite direction. If this reaction is 10, this reaction will be 10 in opposite direction. So how many unknowns do you have here? I believe we have only 2. Because this value will be the same like this. This value will be the same like this. So how many unknowns, how many reactions are unknowns? Only 2. Only 2. So if you have hinge or pin connection and you did separation, at this separation we have only 2 unknowns, not 4. 2 unknowns. 2 unknowns. Okay? So let's do it. For this structure, how many hinge connection do you have? We have pin or hinge connection at this location. So we have to do separation. This part alone and this part alone. This support is hinge. So we have 2 reactions. This support is hinge. So we have 2 reactions. This connection is hinge connection. So we have 2 reactions on this side And these two reactions can be the same values, but in opposite direction on the other part. So finally, we have 2 here. We have 2 here. And how many reaction here at this location or at this connection? We have only 2, not 4, 2. So finally, R equal 6. 2, 2, 2, 6. How many parts? We have this part and this part, so we have 2 parts. N equal 2. So number of unknowns, which is R equal 6. Number of equations, which is 3n equal 3 times 2 equal 6. So finally, number of unknowns equal the number of equations. If the number of unknowns equal the number of equations, your structure will be stable and determined. So the final conclusion, the structure is stable and determined. Guys, remember, I told you, if you have this connection or this type of connection, please do separation. I did. So we have 2 parts, this part and this part. So number of parts, which is n, equal 2. Number of reaction, we have here hinge, so we have 2. We have here hinge, so we have 2. At this connection that you did separation, we have only 2. They look like 4, but they are counted as 2 unknowns. Why counted as 2 unknowns? Because this reaction will be the same like this, same value but opposite direction. This one like this, same value but in opposite direction. So R equals 6, N equal 2. Let's do number of unknowns equal R, number of equation equal 3n. Finally, I found number of equations equal number of unknowns. Your structure will be stable and determined. Any question? Okay. One more. This one. Make sure you can get it. We have here hinge. We have here roller. And we have here pin or hinge connection. So what should I do? What should I do? The first step. Go ahead and put my reactions? No. I have to do separation. If you have pin or hinge connection, you have to do separation first. Okay, let's do this. We have this part and we have this part. You have here hinge support, so we have 2 reactions, 1 and 2. We have here roller, so we have only 1 reaction. You have here hinge or pin connection, so we have only 2 reactions, 1 vertical and 1 horizontal. They will be the same values, but in opposite direction, the horizontal one and the vertical one. All of them will be counted as 2. And these 2 reactions are 2. And this one reaction is 1. So R equal 5, 2, 2, 1. In number of parts, this one and this one, 2. So I will say number of unknowns, which is R equal 5. Number of equations, which is 3n equals 6. The final conclusion, number of equations greater than number of unknowns. So what is the final conclusion? Equations greater than number of unknowns. Equations greater than number of unknowns. Your structure is unstable. So this structure in this example is unstable. This structure is unstable. The last one in this example, we have fixed support, we have pin connection, we have fixed support. Do you remember what is the first step? First step, if you have pin connection, you have to do separation first. This part, and this part. At each pin connection, we have to do separation. Okay, let's put our reactions. You have fixed supports, we have 3. This fixed support, we have 3. This pin connection, we have 2. One vertical and one horizontal will be the same here, but in opposite direction. So these 4 reactions will be counted as 2. This pin connection, we will have these 2 reactions will be the same, but in opposite direction. So these reaction will be counted as 2. So we have 3, 2, 2, and 3. So R equal 10. In how many parts do you have? How many parts here? This part, and this part. So we have 3. Let's do our calculations. Number of unknowns, which is R equal 10. Number of equations, which is 3n, will be 9. So finally, number of unknowns greater than number of equations. Please tell me your final conclusion. If the number of unknowns greater than the number of equations, that means your structure will be stable and indeterminate. Your structure will be stable but indeterminate. We have here a hint saying if the structure is indeterminate, specify the degree of indeterminacy. How many times your structure is indeterminate? Only if the structure is indeterminate. I believe your structure right now is stable and indeterminate. How many times is indeterminate? 1 time. What you mean by 1 time? I means number of unknowns greater than number of equations by 1. 10 and 9, this number is greater than this number by 1. So if the structure is indeterminate, specify the degree of indeterminacy means how many unknowns greater than number of equations. So 10 greater than 9 by 1. Let's do more examples. But before starting example number 2, please, do you have any question? Let me know. Let me know. I'm looking for questions. Everybody is saying no, sir, no, sir. I'm not sure what is the meaning of no. No means two things. Probably everything is good. You can understand everything, or probably you don't care. Okay, so far so good. Thank you, Ben. As I told you, structure is nothing. Structure analysis course is a very important course in structure engineer. You can understand, you can learn, you can improve your GPA. But only pay attention to my live meeting, do your homework, that's it. All the time you need to specify the degree of indeterminacy. And also, your problem in the homework or in the exam will be like this. Exactly. Classify each of the structure as stable, determinate, stable, indeterminate, or unstable. If indeterminate, specify the degree of indeterminacy. Your question will be like this. Exactly. One more example. For this one, we have Hinge Support. We have Hinge Support. And we have Hinge or Pin Connection. At this location only. Make sure only. We don't have this Hinge connection here. We don't have this connection or this type of connection at this corner. So, first step, I have to do separation. This part alone and this part alone. That makes sense? Guys, to be clear with you, I told you if you have Hinge or Pin connection, only do separation. If you don't have this connection, please don't do separation. That makes sense? So we don't have this connection here. So I didn't do separation. Looks good. Okay. So this Hinge support, we have two reactions. This Hinge support, we have two reactions. And this pin or Hinge connection, we have two reactions, one horizontal, one vertical. They will be the same values, but in opposite direction here. This or this reaction will be counted as 2. We have 2 here, and we have another 2 here. So R equal 6. N, what is the number of N? How many parts do you have? Any answer? What is the value of N in this example? How many parts? After separation, how many parts do you have? 2. Thank you. Yes, 2. This part and this part. So N equal to. So I will do my calculations. Number of unknowns, which is R equal 6. Number of equations, which is 3n equals 6. So number of unknowns equal number of equations. If you go back to the categories, I believe your structure will be stable and determined. That's it. That's it. Let's do this one. So guys, we have Hinge Support. We have Roller Support. We have Ping Connection. And we have Ping Connection. We have Ping Connection. So the first step we need to do is separation. I will do separation here and another separation here. Let's do it. We have this part. We have this part. And we have this part. This hinge will give you two reactions here. This roller will give you one reaction here. For this ping connection, we will have two reactions like this, will be opposite like this. So we have two only. For this ping connection, we will have two. This one and this one will be the same, like this one and this one in opposite direction. So this reaction will be counted as two. B sides, two here and one there. So 2, 2, 2, and 1, so R equals 7. In how many parts? How many parts after separation? We have 3 parts. This part, and this part. So we have 3 parts. If you do the calculations, number of unknowns, which is R equals 7. Number of equations, which is 3n equal 9. 3 times 3. That's right, yes. So finally, number of equations greater than number of unknowns. If you go back, I believe your structure will be unstable. I would like you to solve this type of problem like this. Do your separation, put your reaction, what is the number of R, what is the number of N, do your calculations, the total number of unknowns, total number of equations, and what is the relationship between equation and unknown, and finally, tell me what is your conclusion about this structure. Easy? Looks good, I believe. For this one, we have roller, we have roller, we have roller. Do you have any pin connection? Any hinge connection? No. This roller has one reaction. This roller has one reaction. This roller has one reaction. So one of you will say, hey, R equal 3, number of parts equal 1. We don't have separation. So number of unknowns equal 3. Number of equation will be 3. N will be 3. So number of equation equal number of unknowns. This structure is stable and determined. That's wrong. This structure is a special case. How many reactions do you have? 3. All of them are parallel. regardless how many unknowns, how many reactions, how many equations, this structure is unstable because all reactions are parallel. All reactions are parallel. This one, we have this roller connection. We have fixed and we have pin. So this part and this part, this pin support. So we have 2 reaction. Fixed, we have 3 reaction. Roller connection means we have only 1 reaction, will be the same like this one, but in opposite direction. So we have 3, 1, and 2. So number of R will be 6, number of bars will be 2. We have only 2 parts. So I can figure out what is the relationship between number of equations and the number of unknowns. Guys, do you have any questions so far? Do you have any question so far? Okay, thank you, Ben. Okay. Sometimes we have frames with closed loop like this. And we have support here, hinge, and we have support here, roller, for example. What you mean by closed loop? Closed loop? This square or this rectangle can be called closed loop. All members connected together without hinge connection. This connection is not hinge or pin connection. So these members together can make closed loop like this one or this one. How many closed loop do you have here? 1, 2, 3, 4, 5, 6. How many here? 1, 2, 3. So sometimes for frames, we can find closed loop. Each closed loop has 3 unknowns. Each closed loop has 3 unknowns. Or whatever the number of unknowns, the best scenario to solve closed loop to make cut. Just before continue, do you know what is the meaning or what is the difference between cut and separation? What is the meaning of cut and separation? Separation means we have member alone. We have another member alone, connected together here by pin or hinge. So I can do separation because they are two separate members. But if this member is one part with this member, at this time I cannot do separation, but I can do cut. I will do cut. I will cut the member here. If you cut a member like this, we have a member and you did cut this part and this part. At the cut location, we have 3 reactions. They will be the same here, but in opposite direction. These 6 reactions will be counted as 3 unknowns. So, if you have closed loop, I will do cut. At each cut, we have 3 unknowns. Actually, we have 6, but this reaction will be the same like this, but in opposite direction. This reaction will be the same like this, and this one will be the same like this, but in opposite direction. So these 6 reactions can be counted as 3. Let's do this example. We have frame with closed loop, like this one. We have hinge. We have roller. And this one is closed loop. This one is closed loop. This one is closed loop. So we need to do cut. I need to open. I forget to mention this. The main purpose for cut the closed loop to make it open. We need to open this loop. We need to open this loop. We don't need closed loop. So I will do cut like this. I need to open it. So if you did this cut, we will have this part. Like this. You did cut here, cut, cut, cut. And we will have, sorry, this part like this. Don't forget, we have 2 reactions here because it's a hinge. We have 1 reaction here because it's roller. At this cut, we have 3 will be the same. 3 will be the same but in opposite direction. 3 will be the same but opposite direction. 3. So 3, 3, 3, and 3. How many reaction? 2 and 1. So 3 plus 3, 6, 9, 12, 15. How many parts? First part, second part. So n equal 2. Let's do our calculation. Number of unknowns will be 15. Number of equations will be 3n equal 3 times 2 equals 6. So number of unknowns greater than number of equations. Your structure will be stable, but indeterminate. If the structure is indeterminate, specify the degree of indeterminacy. What do you think? How many times? How many times this structure is indeterminate? So how many unknowns greater than number of equations? 9? 9 times. The number of unknowns is 15, number of equation is 6, so 15 is greater than 6 by 9. So this structure is indeterminate. How many times? 9 times. This is called degree of indeterminacy. One more time. One more time. For this structure, I will do cut here. That's enough? That's enough? No. We need to open each closed loop. If you did this cut, I'm still have this closed loop and this closed loop and this closed loop. So I will do another cut. Cut number 2. Don't forget, we have here hinge. We have fixed. We have hinge. If you do these cuts, we will have this part. And this part. And this part. How many reaction? 2. How many reaction? 3. How many reaction? 2. At this cut, we have 3. 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 So how many reaction do you have? 2, 3, 2. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 24, 26, 28, 31. How many parts do you have? We have only 2 parts. This part, I'm sorry, 3 parts. This part, and this part. So number of unknowns equal 31. Number of equations, 3n equal 9. So this structure will be stable, but indeterminate. How many times? This structure is indeterminate. I believe it will be 22 times.